moving on to here. When we looked at everything yesterday, it was a nice shortcut to use trig form. And same thing here, like if you had to do something like this problem that's raised to the 14th power, that would take an awful lot of time, right, to do in standard form. So you'd have to multiply these two, maybe using the box, and then get that answer, multiply it by again, and that would be to the 3rd power, right? And you'd have to do this 14 times, like draw a box, 14 different boxes before you could actually raise this to the 14th power, which would take forever, right? So in trig form, all of it is a lot shorter, it's a lot easier, so that's why we're using it, that's why you're learning it. Okay. So today we have a rule for all the exponents. All right, so here we're going to have a very similar formula, only that we're going to have r raised to some power, so the radius will become just r to that power, and then we'll multiply each theta by the same power. Right? The trick is, though, this has to is that this has to be in trig form, and you'll notice, like on the first problems, right here, these are not in trig form. So that's step 1, is get it in trig form. Now, if you recognize the location of it as being on the unit circle, right, it's kind of easy. Get this here. It's kind of easier. If not, then you have to do it the long way. So right here, if we look at this, root 3 is like 1.6, down 1, it's like somewhere around here, right? So we don't recognize that being on the unit circle, really. Okay, so, which means you have to do the Pythagorean theorem, right, to find the radius. So we have root 3, and this is -1. So we can find the radius just by doing that. R squared equals a squared plus b squared, right? So root 3 squared plus -1 squared. So we got 3 plus 1. And that means, I'll just put the square root, so we'll end up with, what, 2. So that's why we didn't recognize these numbers, because it's a radius of 2, not on the unit circle. If it was a 1, we should have recognized it. And then we also have to find the theta, right here. Right there. And if we don't know what that theta is, then we have to do arctangent, right? So we have the rise, we have the run, opposite over adjacent. Right. That might require a calculator. It's okay if it does. Punch that in. Arctangent of the rise over run always gives you an angle. And with those two pieces of information, we can now start using our actual formula. Right? So we can start putting it in this format and then applying the formula. So first we could put it in the format, which we got, what, 2? And we have all this stuff. Cosine plus I sine. Right? And then we have the angle. What did it come out to be? All right. $30? Close. So yeah, -30 we get. negative 30 degrees for both. You could do this in radians as well, like negative pi over 6. It wouldn't be wrong. That's fine. Now you could apply the actual rule. Oh no, we forgot one thing. We have our exponent to the third power, so that's to the third power. Need that. So we have 2 to the third. All right, and then we'll have cosine, leave a little more room, I sine. And we'll have 3 times that negative 30. Right. So we've used the property, and then from here, just all simplifying. Right. So we got 8 cosine of, I'll put all this stuff in first. It's like negative 90. And then keep going all the way to standard. And cosine of negative 90, 0. Sine of negative 90, negative 1. And then finally it simplifies to 8 times 0 is just 0. 8 times the negative 1i would be negative 8i. That's your final answer. We should probably put some equal signs in here. There we go. So a little bit of work, but if you had to do this in standard form, I wrote it out down here, this is what it looked like. I have to break just this up. I'd have to do just square it first, multiply those two together, combine all the like terms, simplify, and then multiply it again. Combine all the terms, simplify, all that good stuff, and it finally gets down to the same answer, right? It still equals 8i. So we can do the problems both ways, both in standard and trigonometric. The idea is that, okay, these look like about the same amount of work, but as soon as if I kick this up to 14, like on that initial problem on the front, right, this would take way longer than just doing this. All right, so our two ways, you do get the same answer, but this one is definitely shorter. So that's why there's a need to learn it, and it helps us find answers a lot easier. All right, so go ahead and try that on the next one. This is to the fourth power. Very similar. So next we can do the same, very similar, not the same, but for finding fourth roots, meaning finding fractional exponents. So recall that a square root is really what number times itself 2 times, and that is the same as a 1/2 power. So we could find square roots and third roots and fourth roots and fifth roots for these problems, right? Just using the same old exponent rule with a little twist. Okay. So recall that when you're finding roots, kind of like on a parabola, the roots are like x-intercepts, right? And this is a quadratic, meaning it's raised to the second power. That says how many roots there are. So when it says there are 4 roots, or find the fourth roots of, that means there's 4 answers total. So you're looking for 4 total answers because of this. Fourth roots. Right? Four answers or 4 roots total. So that way you know if you're actually done. And it sometimes helps to convert this or write this in the standard form. So what it's asking is 16 is the same as 16 minus 0i or plus 0r, I guess. And the fourth root is the 1/4 power. So just like before, we need to get the trig equation, trigonometric form equation. So looking at this, 16, where is that on the graph? 16 plus 0i, where is that? Yeah, just right here, 16. And then what is the radius? R is 16. And what is theta? 0, yep, 0. It equals 0. Which sometimes throw people off. Like, if there's no angle, you know, but just remember where the unit circle starts. That's exactly where it is. Right? It's not a unit circle because the radius is 16, but it's still on degree 0, radian 0 right there. So with that, you can write your equation. Right? So we'll have 16, right? And then cosine plus I sine. And it's just going to be 0, right? For both of these. And this time our exponent is a fraction. So from here, just do the same thing we just did up here. Nothing changes except that you're multiplying by a fraction, other than other than an integer, rather than an integer. So we got 16 to the 1/4. That's going to bother me. 16 to the 1/4, and then we'll have cosine. And there's not a whole lot going on here because, there we go. Because we're just multiplying everything by 0. So we'll get, I'll write the steps out, but this doesn't always have to be 0 right here. So that way you have it all worked out for future problems. Good. And 16 to the 1/4 power is 2. We'll have cosine of 0. And sine of 0. So we got 2 times, let's see here, cosine of 0 is 1, sine of 0 is 0. And we just get an answer. It's somewhat underwhelming, that we get an answer of 2. which we kind of already knew that was an answer. If I asked you ahead of, before, without knowing all this stuff, what's the fourth root of 16, you'd probably come up with 2 as an answer. Okay. Make this a little smaller. Okay. Now, the cool thing about this method for the roots, so we need 3 more answers. Okay? We need to get 3 answers. 3 more answers anyway. And the cool thing about this method is that it has a graphical interpretation. So what we did is we just found that the first answer, right, is right here at 2. Okay. And what this part up here says, offset angle. So from the first solution, after you do the work and you get the first solution, it tells you that the next solutions, let's see here, we got 360 divided by, we're getting 4 total answers. So it means there's another solution every 90 degrees. So if I have the first solution, all I have to do is rotate 90 degrees, positive direction, and keep on going that way until I end up back where I started, and I get all the other solutions. So if I'm at 2 and I go 90 degrees, that would be right here. What is this solution? What would that be? On the complex plane, though. 2i. Alright, we're on the complex plane. And if I did another 90 degrees, what would I have over here? -2, which we already kind of knew. We could have figured that out too, that if 2 to the 4th power is 16, -2 to the 4th power is also 16. But now I do a fourth rotation, and I get my 4th answer, which is -2i. So this gives me all 4 answers. I really only had to show the work for the first one, simply because these are actually on the axes. Now, if these were like in the middle of space, I probably wouldn't be getting these as easy, right? I can just see them from here. So what we can do is we can go through and just show the work for each one of them. So for this one, what we can do is we can write it out starting right from here. I don't need to redo the whole property and the 1/4 and the multiplying. I just need to take this right here. Instead of 0, let's put in 90 degrees. So if I do this and say cosine 90 plus I sine 90, right, we'll have 0 plus I, or 1i, I guess. Yeah, 1i. And then we get an answer of 2i. So that matches what I got here. So if I can't do it graphically, I just have to do a little bit of solving. I don't have to do this full thing, but just a little bit. And I'm going to do the rest of them as well, just to show where they come from. So this one would be cosine, 2 times cosine 180 plus I sine 180. -1 plus 0i. And that gives me the answer -2. That's right here. And then one more to go. 2 times cosine 270 plus I sine 270. And that will give me the, 0 again, and this time will be -1i. So I get my answer of negative 2i. Of course, that's right there. So your work, right, and your graph rotation should match up with each other in some fashion. But it's nice to see, especially on like fourth roots, this with 4 roots, you're always going to get 90-degree rotation. So fourth is kind of an easier problem. You can imagine that this fifth root, these angles here, be 360 divided by 5. You have 72-degree rotations. It wouldn't be looking as nice. So there are definitely some of these fourth roots definitely being an easier computation because of that. All right, so next, we've got one more to go on the next page. I kind of started it off already, just in case we ran short on time. All right, so from here, what is the angle of rotation? Yeah, it's going to be 120 this time. So it'll be 360 divided by 3 roots this time, making each one 120 degrees. So remember, always start from the first solution, not from the original location, because sometimes you go over here and say, oh yeah, 120 from here. No, from the first solution. So do the whole formula, get your first solution, and then from there, 120 degrees. Right, so this is 120 degrees right there. And you need to know what that location is, and then do another 120 degrees, right here, and then what this is right here, and then of course another 120 puts you back to where you started. If you kept on going and just kept on adding 120 over and over, you just inevitably end up getting another answer of I. So if you ever see you're doing this and you get a repeated answer, that just means you went too many times. So over here, since we have this radius of 1, doesn't really help us to have that. It doesn't change anything if we get rid of it. So we can just take, remember, the part after the formula. So we already did the formula right here. So you want to take this part right there and just say cosine, let's see here. This is 90 plus 120 is 210. So cosine 210 plus I sine 210. And technically there's a 1 in there. Doesn't change the answer, but I'll put it there because it's not always going to be 1. So here we'll get this is on the unit circle, right? Third quadrant, so both these are negative. Negative root 3 over 2 minus 1/2 I. So that's what this second root will be. And over here, you can see it's also a 30-degree reference angle. So you might be able to skip this part just by symmetry alone. And say it is positive root 3 over 2. Still minus 1/2 I. And that's the solution right here. And then you could always check each one of these. So you could go here and say, well, you know, as a check, you know, what is I to the third power? Right? And lo and behold, that does equal negative I. And then you could go down here and you could try to, you know, do a lot of work and raise this to the third power, right? And it should come out to negative I. And same thing over here. If you want to check that, raise that to the third power, do all that work, and it will come out to negative I. I'm not sure if the calculator will do that if you type that in, if it actually gives you, you know, that simplified answer, but maybe it's worth checking on just as a way of checking your answers. All right. All right, so we got here number 29, I think we're on. Right? So on your homework, write that on your paper. Make sure you have this whole thing written large and clear. And then tomorrow we'll do a little part 2 and have some time to work in class tomorrow as well.